Everyone, I'm Tanmay and today I'll be presenting my presentation on decoders. So, a decoder is a digital circuit that detects the presence of a specified combination of bits on its inputs and indicates the presence of that code by a specified output. Suppose we are giving input as 0 and 1 on one side, and since according to that input, we'll get the output from other side. It is a 2 is to 4 decoder, and there is general form of decoder in which it has n input lines and to handle n bits, and there are 2 to the power n output lines. So as you can see, 2 input lines and 2 to the power n output lines. 2 to the power 2 is actually 4. In this section, okay, coming to the next slide. So in this slide, we are going to learn about binary decoder. The word binary represents that we are providing the input in binary form. Say 1001 is the binary input, and it is telling that an AND gate can be used as a basic decoding element. AND gate, the representation of AND gate is like this. This is the input punch and this is the output. So AND gate can be used because it produces a high output only when all the inputs are high. So we know in the truth table of AND gate, 1 and 1 produces 1. When all the inputs are high, then only we are getting high output. If 0 and 1 is there, so we are getting 0. So no, it's actually low. So that's why you're using AND gate. So when the binary number 1001 occurs, this can be done by inverting the two middle bits. That is 1001. We are inverting these two bits to the inverting is the applying NOT gate. So 1 1 1 1. It will be after inverting, it will be 1 1 1 1. So if you pass it from the AND gate, we'll get the output as 1. So in this slide, it is the representation of the previous slide where we were giving our input as 1001 and we are using AND gate. So for getting the output as 1, we are using two NOT gates or inverting gates. These are the inverting gates which are inverting the 0 and 0 to 1 and 1. So basically, we are giving all the inputs to the AND gate as 1 1 1 1. So it is giving the output as 1. We can see here that if four inputs are there, A0, A1, A2 and A3. So the middle one are that 1 and 2 was 0. 1 and 2 were actually 0. So we need to invert that for getting 1 as the output. So you can see this bar. This represents the inversion operator. So A3, A2 bar and A1, A0. These two have bar. These two have bar. We are using this as the logic circuits diagram. Let's understand decoder in more depth. A decoder is used to decode encoded information, and it has n data inputs and 2 to the power n outputs. N inputs and 2 to the power n outputs. That is, for two inputs, we will have 2 to the power n is equal to 4. 2 to the power 2 is equal to 4. So we will have 4 outputs. And it also has enable. Enable is used to remove errors which we will get by switching bounce switching and race hazards. Then we use enable to eliminate that errors which occurs during the change of the output state and during the change of the input states. We use enable. So here we have the first type of decoder, that is 2 is to 4 decoder circuit. So this is the block diagram of 2 is to 4 decoder, which has two input lines and four output lines. That's why the name is 2 is to 4 decoder, and one 11 enable line is also there. So coming to the truth table of 2 is to 4 decoder, we have the enable line as 1 and there are two inputs. So 0 and 0, we are getting the output y not as 1, y not as high. So this input is high for 0 and 0. For next input, that is 0 and 1, we have the y1 as high. This one is high. Rest all are low. For the third input 1 0, we have the second y2, the third one is high. Rest all are 0. For 1 1, we have the last one, that is y3, which is 0, which is 1. Y3 is high. Rest all are 0. And this is the truth table of 2 is to 4 decoder. And the next one is that this logic circuit diagram. We are using two inverter gates to invert the inputs and four AND gates. And one enable line is also there, which is directly going to all the AND gates, and the inverted inputs are going to the AND gates, two AND gates. So coming to the next type, we have 3 is to 8 decoder. That is, we have 3 input lines and 8 output lines. 3 input lines and 8 output lines. So in these 3 input lines, we are representing with A0, A1 and A2, and we'll have 2 select lines. We'll have 2 select lines for 3 is to 8 decoder. Coming to the next slide, we'll see the truth table and other things. Coming to the truth table side, we have this IC representation of 3 is to 8 decoder. 74138 is the IC number of 3 is to 8 decoder. And in this truth table, we are actually representing low and low, low. The first input is all three are low. So it will be y naught will be low, represented by low, and rest all will be high. So it's like 0, 0, 0. So the first y0, y will be 0, and rest all will be 1. Coming to the next is low, low, and high. We're getting 1 as high, y1 as high. Then low, high, low, that is y2 as high. So this will be like a diagonal pattern, and rest all will be high. This is making a diagonal, rest all will be high. Coming to the next slide. So this is a 4 is to 16 decoder, not in our syllabus, but still for knowledge. Uh, we are giving the first input 0, 0, 0, 0, and here also we are getting the y0 as 1, y0 as 1, and these all are the binary representation of this number. Like 15, for 15 we have the binary representation as 8, 4, 2, 1. So the sum will be 15. That's why all the outputs are, all the inputs are 1. So it is actually representing the binary number of 15. And for this input 1111, we are getting the output here, the last one. The last one will be 0. Y15 will be 0, representing that the output is Y15. And for 0, it is represented by Y0. For 1, it is represented by Y1 of 0. So, but like this, all the inputs are given to the decoder, 4 is to 16 decoder, and the output, the number which representing the binary number is 0, and rest all will be 1. So, coming to this slide, we have 3 is to 8 decoder and 2 is to 4 decoder. We have to convert 3 is to 8 decoder to 2 is to 4 decoder. Actually, what we are doing is the 3 input lines, we have to convert that to 2 input lines, and 8 output lines will be converted to 4 output lines. We'll see what to do in the next slide. I'll explain. So let's move to the next slide. So here we have a question which is telling that f is equal to sigma of 0, 2, 3, 5, 6, which is representing the min terms. So I have created the truth table which has 3 variables and 1 output. For 0 we have output as high, 0, 1, 1. For 5 again 1, for 6 again 1, and for 7 0. So here we have to make group of 2. Starting from the 0 1, we have to make group, and we'll reduce it to 2 variables. So for the input, we are taking A and B. We are creating another truth table for the 2 is to 4 decoder, and the output is same Y, but the output depends on C. That's why we are not taking C here. So for the first input, we have 0 and 0 because A is also 0, B is also 0 in both the cases. And the output depends on C. So if C is 0, output is 1. If C is 1, output is 0. So it actually represents that C bar. Whatever the input of C is, the output will be the inverted for that. And for the second case, A is 0 and B is 1. A0, B1, we are getting output always as 1. So the output is always 1. So this. Coming back. Next is A is 1 and B is 0. A1, B0. Output is 0 and 1, which is actually equal to the C. So we'll write C here. And for this last case, 1 and 1, output, if the input for C is 0, output is 1. If the input for C is 1, output is 0, which is actually again C bar. 0. And last case was 1, 1. We're getting C bar again. So this is how you convert the 3 is to 8 decoder, that is 3 variable decoder, to 2 variable decoder. Okay, now let's come to the next slide. Coming to the application of decoder, decoder are used in many types of applications. One example is in computers for input and output selection. So it is like decoders are widely used, but we are taking one example as the input and output selection. These all are input output ports which are using enable lines, as well as this is the port address decoder which uh, tells us the address, like according to the input what we will provide it, the output will transmit the signal to the our input and output devices. So it is used in this, basically it is used in computers for input output selection. So in BCD, we actually convert the binary numbers, sorry, the decimal digits to binary, and according to that, we'll get the outputs. So here we have the first number 0. So for 0000, we're getting the output as decoding function is this. For the input, let's take 5. So 5 will be represented as the sum of 4 and 1. So that's why in the truth table, the 4 and 1 will be high, 1, 1, and rest all will be 0. And we will get the invert in the A3 bar, A2, A1 bar, and A0. The bar is removed because these are high and these are 0. So for 5, we are getting this. Let's take the same for 9. 9 will have 8 and 1 as the sum. 8 and 1 will be 9. So 1001. So that's why that will be same as we'll remove bar from here, and just this will have this. This will be representing that by a decimal number 9. This is the graph for BCD decoder, input output graph. If the input is 0 in all ports, then only the 0 will be low, rest all are high. If the input is 1, that is the decimal digit is 1, then 0 will be high and 1 will be low. Only 1 will be low, rest all will be high, representing that the input is 1. Here we have a 7 segment decoder. 7 segment is not in our syllabus, although, but still it is widely used in LED displays and all. That's why let's learn the working of that 7 segment decoder. So we have this pin diagram and logic diagram for 7 segment decoder. 7 segments are actually representation of 7 segments. It is represented by A1, 1, 2, 3, 4, 5, 6, 7. There are 7 segments which represent numbers, these natural numbers. Any combination it is represented by using 7 segment decoder nowadays in many devices and all. Now the decoder used, we actually see this, the ports 2 and 1 for the output 2 and 1. If it is high, like 1, 1, the sum is 3, right? So we are getting output as 3. If the input is 8 and 1, that is 9. So we are getting output as 9. this is the basic working of the 7 segment decoder, and it can go to 0 to 9. So here we are using decoder for full adder. We are implementing functions, that is full adder and half adder. We can use decoders for that, which we have to, the input will vary according to the sum and carry functions. Like for sum we have 1, 2 and 4, 7. See here you can see in the truth table, for sum 1, 2 and 4, 7 will be high. For carry the same goes, the 3, 5, 6, 7 will high is high. So in this decoder, we are using 3 to 8 decoder, and the inputs will vary according to the codes what we are giving in the truth table. And for some, it is actually showing what we will get as the output. So this is the last slide, and this brings my presentation to an end. Thank you.